This conversation is powered by Google Illuminate. Check out illuminate.google.com for more. Ever wondered why things seem to curve as they move across the Earth? It's not magic, it's physics. We're diving into the Coriolis effect 2D today.
Exactly. It's a fascinating phenomenon that affects everything from weather patterns to airplane flights.
So it's not just some theoretical thing, right? It actually impacts our daily lives.
Absolutely. Think about how hurricanes spin, or how projectiles don't always travel in perfectly straight lines.
Whoa, that's wild. So let's break down this Coriolis effect. What's the basic idea? So what exactly is the Coriolis effect? Is it like some invisible force pushing things around?
Not exactly a force, more of an apparent deflection. It's all about how we observe motion on a rotating planet.
Rotating planet, so the Earth's spin is key here?
Precisely. Because the Earth is spinning, anything moving across its surface appears to curve.
This simulation is called Coriolis effect 2D. How does a 2D model help us understand something that happens in 3D?
It simplifies things. We can focus on the horizontal deflection without the added complexity of vertical movement.
So it's like a simplified version to grasp the core concept before tackling the full 3D picture.
Exactly. It makes the effect much easier to visualize and understand.
The simulation is available online, right? Is it interactive?
Yes, you can adjust parameters like rotation speed and projectile velocity to see how they affect the deflection.
So you can play around with it and see the effect in action? That sounds cool.
It's a great way to experiment and get a feel for how the Coriolis effect works.
So beyond the simulation, what are some real-world examples of the Coriolis effect in action?
Hurricanes are a classic example. Their rotation is influenced by the Coriolis effect.
So that's why they spin? I always wondered about that.
Exactly. And it also affects long-range projectile trajectories like artillery shells or even airplanes.
The paper mentions some educational resources. Are there any hands-on activities that can help illustrate the Coriolis effect?
Absolutely. Rotating a platform with a marble is a simple yet effective demonstration.
So a simple experiment can really bring the concept to life?
Yes, it helps students visualize the deflection directly. It's much more engaging than just reading about it.
The paper also links to videos and other online resources. Is there anything else you'd recommend for someone wanting to learn more?
Definitely check out the National Geographic video. It explains the effect clearly and visually.
So there are plenty of resources out there to delve deeper into this topic?
Absolutely. From simple experiments to detailed explanations, there's something for everyone.
The paper credits Fu Kun Kwong, Danwei Tiong, and Lukang. What can you tell us about the creators of this simulation?
They're clearly passionate about making physics accessible and engaging. The simulation is a testament to their dedication.
So it's a collaborative effort to make learning fun and easy?
Exactly. They've created a valuable tool for educators and students alike.
The paper mentions a license. Is this simulation freely available for use?
Yes, it's released under a Creative Commons license, meaning it can be used and shared widely.
So anyone can use it for educational purposes?
Exactly. It's a great example of open educational resources.
The simulation is hosted on iwanttostudy.org, right? What's that website all about?
It's a great resource for educational materials, particularly in science and technology.
So it's a central hub for interactive learning resources?
Yes, a valuable resource for educators and students.
The second document shows a different website, also using Apache. What's the significance of that?
It shows the widespread use of open source platforms for hosting educational content.
So it's not just one isolated project, but part of a larger movement?
Exactly. Many educational resources utilize similar platforms.
The second document emphasizes open educational resources. Why is that important?
It promotes accessibility and affordability of educational materials, making learning more inclusive.
So it's about breaking down barriers to education.
Precisely, making quality education available to everyone. The Coriolis effect, while seemingly complex, is actually quite accessible with the right tools and resources.
That was a great discussion. Thanks for shedding light on this fascinating topic.